Today I will discuss about superposition of two perpendicular simple harmonic oscillations. Today I will discuss about superposition of two perpendicular harmonic oscillations having different frequencies. It is interesting because if a particle is subjected simultaneously by two perpendicular simple harmonic motions of different frequencies, then the particle moves in a special pattern. That means if a particle is subjected simultaneously by two perpendicular simple harmonic motions of different frequencies, then the particle moves in a special pattern. If we plot the movement of the particle, then we will get different figures at different time, and these figures are changed in a cyclic order. That means we get repeatedly the same figure after a particular time. Scientist J.A. Lysageus made the extensive study of this motion, that is the motion of particle when two perpendicular simple harmonic oscillator is subjected simultaneously to a particle. Then the curve of the movement of the particle after his name is termed as Lysageus figure. So by definition we can say that the Lysageus figure is the pattern that are traced by a particle which is subjected simultaneously of two perpendicular simple harmonic motions of different frequencies are known as Lysageus figure. Now we consider the case when the frequencies are equal for two perpendicular simple harmonic motion. Let us suppose two perpendicular simple harmonic motions along x-axis and y-axis with frequencies omega be represented respectively by x equal to a1 cos omega t and y equal to a2 cos omega t plus delta. First one is along x-axis and second one perpendicularly is along y-axis. A1, A2 are their amplitudes, omega is the angular frequency and delta is the phase difference between them. Now our aim is to find the locus of the instantaneous particle position by eliminating time t from the above equation. So from equation 2 we say y by a2 equal to cos omega t into cos delta minus sin omega t into sin delta. Now since cos omega t equal to x by a1 from equation 1, then sin omega t equal to root over of 1 minus cos square omega t equal to root over of 1 minus x square by a1 square. Therefore y by a2 equal to equation 2 y by a2 equal to x by a1 cos delta minus root over of 1 minus x square by a1 square into sin delta. By simplification we get x by a1 cos delta minus y by a2 equal to root over of 1 minus x square by a1 square into sin delta. Now squaring we get x square by a1 square plus y square by a2 square minus 2xy divided by a1 a2 times cos delta equal to sin square delta. This is a general equation of an ellipse. Hence the path followed by the particle which is subjected to two perpendicular simple harmonic motions of equal frequencies is an ellipse. It is very interesting, is an ellipse. That means the equation 3 represented the general equation of an ellipse. Now, special case. Now, from equation 3, if we put delta equal to 0, then cos delta becomes 1 and sin square delta becomes 0. Therefore, we say that equation 3 ultimately becomes y minus a2 by a1 into x in whole square equal to 0. This represents two coincidence straight line. This represents two coincidence straight line. These straight lines are y equal to a2 by a1 into x. Now where a2 by a1 is the slope of the curve which is passing through the origin, and this slope is the positive slope. So from equation 1 and 2, that means x equal to a1 cos omega t and y equal to a2 cos omega t plus delta. Here we see that the maximum and minimum value of x and y are respectively plus a1 minus a1 and plus a2 minus a2. Here this is the max. If we take delta equal to 0, then equation 1 equal to this and equation 2 y equal to a2 cos omega t. So the maximum value of x and y is maximum and minimum value of x and y are plus a1 minus a1 and plus a2 minus a2. Hence the resultant motion, this is important, the maximum and minimum value of x and y plus a1 minus a1, but this is maximum minimum, and while the value of y, the maximum value is plus a2, minimum value minus a2. Hence the resultant motion of the motion is in rectilinear and takes place along a diagonal of a rectangle of sides 2a1 and 2a2. How I can say rectangular? Why rectangular? A diagonal of a rectangular? Because the maximum value of x and y are plus a1 minus a1 and plus a2 minus a2, and the ellipse becomes two straight line. These are y equal to a2 by a1 into x. This is the straight line which is the slope is positive and passing through the origin. That means the motion of a particle is along the diagonal of the rectangle of side 2a1 and 2a2. That means the diagonal is along a diagonal of a rectangle of sides 2a1 and 2a2. Now we have to determine the direction of motion. So first we take delta equal to 0 in equation 1 and 2, then we get x equal to a1 cos omega t, y equal to a2 cos omega t. At time t equal to 0, x equal to a1 and y equal to a2. At time t equal to 0, that means when the motion first starts to move the particle, the motion starts just at time t equal to 0, x equal to a1 and y equal to a2. That means the particle is at point P at t equal to 0 as shown in this figure. The particle at point P at time t equal to 0. Now t increases. The value of both x and y, x and y both value decreases, and after some time it becomes 0 and then negative. So when increase the time, cosine term begin to decrease, and when omega t equal to pi by 2, x and y become 0. So the particle moves from p to 0. So the particle moves from, when t omega t equal to pi by 2, the particle moves from p to 0. Again, when time again increases, that means when omega t equal to pi, then x equal to minus a1 and y equal to minus a2. That is, the particle moves from O to P prime. Particle moves from O to P prime. Then what happen? If we again increase the time, then the particle moves from P prime to O and then O to P prime. Then successively, after time t increases, then the motion of the particle is along P O P prime and then P prime O P. From here we see the, when delta equal to 0, the motion of the particle is along the line, diagonal straight line from P to 0, 0 to P prime, and again P prime to 0 and 0, P prime to O and O to P prime. And in this way the particle moves, P O P prime and P prime O P. Now second case. Now when delta equal to pi by 2, what happened? Equation 3 becomes an ellipse whose principal axis lie along x and y axis as shown in figure 2. From equation 3 we get delta equal to pi by 2. If delta equal to pi by 2, then equation 3 becomes, where is equation 3? Now this is equation 3. This is equation 3. This is equation 3. This is equation 3. And if delta equal to pi by 2, then cos delta equal to 0 and sin square delta equal to 1. Therefore, we get only the first term, second term. This is 0 and this is 1. That means x square by a1 square plus y square by a2 square equal to 1 when delta equal to pi by 2. Now, which is an equation of an ellipse whose principal axis along x and y axis as shown in figure 2. Now again the question arises, how we calculate the motion of the particle, the direction of motion of the particle. Again, when delta equal to pi by 2, then equation 1 and 2 becomes x equal to a1 cos omega t and y equal to a2 cos omega t plus pi by 2. That means minus a2 sin omega t. Now at t equal to 0, x equal to a1 and t equal to 0, y equal to 0. That means at t equal to 0, from this equation we get x equal to a1, and at t equal to 0, from this equation we get y equal to 0. That means the position of the particle at time t equal to 0 when delta equal to pi by 2, a1 0. That means this is the point a1 0. That means this P point is the starting point for delta equal to pi by 2. Now, if time increases, what happen? If time increases, then what happen? From this equation, at time t equal to 0, we say, I already say x equal to a1 and y equal to 0. That means the particle is in at p in figure 2 at time t equal to 0. Now with increase of time from t equal to 0, the value of x increases from its maximum value, decreases from its maximum value, because x equal to a1 cos omega t, maximum positive value a1, and y begins to negative. So when omega t equal to pi by 2, x becomes 0 and y becomes minus a2. x becomes 0, omega t equal to pi by 2, then x becomes 0 and y become minus a2. That means the particle is coming from p to q. Again, if we increase the time, then we will get sorry, the particle moves from P to Q during this time, and the motion of the particle is indicated by the arrow in figure 2. That means the clockwise movement of the particle is along clockwise direction by the ellipse equal ellipse. The equation of the ellipse is x square by a1 square plus y square by a2 square equal to 1. Now if a1 and a2 equal to a, when e1 and a2 equal to same with equal to a, the ellipse becomes into a circle, x square plus y square equal to a square. A special case 3. Now when delta equal to pi, then what happens? Now from equation 3, delta equal to pi, we get x square by 1 square plus y square by 2 square plus 2xy divided by a1 a2 equal to 0, or x plus a2 by a1 times x whole square equal to 0. This represents again two coincident straight line, y equal to minus a2 by a1 into x. Here it is noticeable that the slope of the curve is negative. The value is a2 by a1, but the sign is negative and passing through the origin. The ellipse is degenerates into a straight line as shown in figure 3. That means like this. So first one, the motion of the particle starts from here to here. Here motion by this line, the particle trace the motion this along this straight line. The slope of the straight line is minus a2 by a1. Now special case for delta equal to 3 pi by 2. What happened? Equation 3 becomes x square by a1 square plus a2 square by a2 square, x square by a1 square plus y square by a2 square equal to 1, which is an equation of the ellipse whose principal axes lie along x and y axis as shown in figure 3. To obtain the direction of motion of the particle, we put delta equal to 3 pi by 2 in equation 1 and 2, and we get x equal to a1 cos omega t and y equal to a2 cos omega t plus 3 pi by 2 equal to a2 sin omega t. Here we get the same ellipse as shown in case 2, but the above equation, this is the same equation as this is the same equation this is the same ellipse, but here the above equation indicate that the motion is in opposite direction. This is cos a1 cos omega t, y equal to a2 sin omega t, and here it was this happened as x equal to x equal to this equation x square by 1 square plus y square by a2 square, and we get this the direction of motion is along the arrow, and x equal to a1 cos omega t and y equal to minus a2 sin omega t. But here x equal to a1 cos omega t, y equal to minus a2 sin omega t. But when delta equal to 3 pi by 2, x equal to a1 cos omega t and y equal to, instead of minus, it becomes a2 sin omega t. That means the above equation represents the motion is in opposite direction from the previous one. In the previous case, delta equal to pi by 2, it was clockwise, but in this case, delta equal to 3 pi by 2, the motion is counterclockwise. Here we have considered only 4 values of delta. If we take more different values of delta in the range 0 to 2 pi, then we will get different types of curves, and all these curves are known as Lissajous figure. So if we take any value of delta, then we get different curve. We only take 4 values of delta, that means 0, pi by 2, pi, 3 pi by 2. But if we take more different values of delta within 0 to 2 pi, then we will get different types of curve, and all these curves are known as Lissajous figure. Here this is last homework. We just